Today we'll discuss imaginary numbers. Remember that in the real number system, it's not possible to take the square roots of negative numbers, because whenever a real number is squared, it's non-negative. This fact has a ramification for finding x-intercepts of a parabola, as exercise number 1 will illustrate. So in exercise 1, we are given y equals x squared, or f of x equals x squared. Now let's think about the equation of f of x equals x squared plus 1. Well, how is that shifted to produce f of x? That's a translation up 1 unit. So let's create a quick sketch of that on these axes. So this is my parent parabola, whose vertex is 0, 0. When I translate that up 1 unit, its vertex becomes 0, 1. What can be said about the x-intercepts? There are none. This parabola never touches the x-axis. And remember, the x-intercepts are the real roots. So if there are no x-intercepts, there are no real roots. If we solve this algebraically, we would subtract 1 from both sides and get x squared equals negative 1. And then when we attempt to square root that negative 1, we would have to stop, because we would say that's not a real number. Well, it's not. It's now what we call an imaginary number. Whenever we have a negative under a square root, that is an imaginary number. And in fact, the square root of negative 1 is what we call the imaginary unit, and we can now rename it as I, so that now we can continue solving these equations with our imaginary number system. So I is the square root of negative 1. That's a huge concept, and we call this the imaginary unit. So from now on, when we want to simplify and we have negatives under a square root, we know that they're not real numbers, they're imaginary numbers, but we can continue. Here's how you want to think about it, and here's how you should write it in the beginning. When you see something like the square root of negative 9, you want to rewrite that as the square root of negative 1 times the square root of positive 9. We haven't changed meaning. Negative 1 times 9 is negative 9. But now we know that the square root of negative 1 is I, so we call that I. We also know that the square root of 9 is 3. So this is I times 3. We clean that up. We put our coefficients in front of our variable looking things and call this 3I. So the square root of negative 9 is now 3I. The square root of 100, well, that's the square root of negative 1 times the square root of positive 100. We know that the square root of 100 is 10. We know that the square root of negative 1 is I. So the square root of negative 100 is 10I. Moving on to the square root of negative 32, again, we can do the same thing. However, 32 is not a perfect square, so we have to work a little harder at it. So we still take out our negative, and as soon as I see a negative under the square root, I just rewrite it as I. And then I'll worry about the positive 32. Well, 32 is 16 times 2. The square root of 16 is 4. The square root of 2 is irrational, so that has to stay under the square root. So the square root of 16 comes out as 4. The square root of 2 stays underneath. So when I clean up the square root of negative 32, it's 4I square root of 2. The same is true for the square root of negative 18. The negative comes out as I. 18 is 9 times 2. The square root of 9 is 3. The square root of 2 does not simplify, so that stays underneath. Okay. Take a minute to write this down in your cumulative notes and maybe an example or two. Now that we know about the imaginary number system, we can finish solving some of these quadratics where before we'd have to stop and say no real solutions. So I'll show you one, and then I'll have you try the other two on your own. So in part A, 5x squared plus 8 equals negative 12. I need to get x squared alone, so first I'll subtract 8. 5x squared equals negative 20. I'll divide by 5 to get x squared alone. So x squared is negative 4. We undo squaring by square rooting, and we're solving, so we need both roots, so we don't want to forget our plus or minus. So x is the positive or negative square root of negative 4. And now again, instead of stopping there, I can say, oh, well, the square root of negative 1 is I, the square root of 4 is 2, so I can clean this up and say the roots of this are plus or minus 2i. They're still not real roots, but now we know how to show the actual imaginary roots. Again, pause and give parts B and C a try on your own.
So let's take a look at exercise 3. Which of the following is equivalent to 5i times 6i? Well, I behaves a little bit as a variable, so we treat it the same in the beginning. So first we would multiply our coefficients. 5 times 6 is 30. And then we would multiply our i's. I times I is I squared. Well, we now know that I is the square root of negative 1. So this is really 30 times the square root of negative 1 squared. Keep in mind that squaring undoes square rooting. So this squared takes out the square root, and I squared is really equal to negative 1. This is another big idea that we'll be using a lot throughout the course. So when I simplify this completely, this is 30 times negative 1, which is negative 30. In this case, choice 3. But again, I squared equaling negative 1 is a very big idea in Algebra 2 and other courses. Make sure you get that down. And in fact, the powers of I display a really cool pattern that allows us to simplify very large powers. So we're going to discover that pattern in exercise 4, and then I'll show you a way of remembering it, and we'll continue. So here we're going to simplify each of the following powers of I. Well, I to the first, anything to the first stays the same. That is I. That's given to us. I squared, we just discovered, is negative 1. What about I cubed? Well, I could rewrite I cubed as I squared times I, using our exponent rules. And we just discovered that I squared is negative 1. So this would be negative 1 times I, or negative I. So I cubed is negative I. Let's try I to the fourth. Well, we could think of I to the fourth as I cubed times I. Well, I cubed is negative I times I. A negative I times I would be negative I squared. But we know that I squared is negative 1, so this is negative, negative 1, or positive 1. I to the fourth is positive 1. We can try to continue and see what's happening with this pattern. I to the fifth, well, we could consider that I to the fourth times I. Well, I to the fourth is 1. 1 times I will be I. I to the fifth is I. I to the sixth, we could think of that as I to the fifth times I. Well, I to the fifth is I, so this is I times I, which is I squared. Oh, wait a minute. I squared, we learned earlier, is negative 1. So I to the sixth is also negative 1. I to the seventh, well, that's I to the sixth times I, but we just said I to the sixth is negative 1. So negative 1 times I is negative I, just like I to the third. And finally, for pattern discovery, I to the eighth we could think of as I to the seventh times I. Well, I to the seventh is negative I times I is negative I squared, but I squared is negative 1, so negative, negative 1 is positive 1. So if you look at what's happening here, is every fourth power of I gives me the same answer. So I to the first is the same as I to the fifth. I squared, I to the sixth. I cubed, I to the seventh, and so on. You could certainly be listing them all the time. There is a quick way to remember them, and I'm going to show you that next, and you'll want to put it immediately in your cumulative notes. This is something that I refer to as the I chart. It's a little play on what you do when you go to the eye doctor, but it's I, the imaginary unit chart. So what we'll do is we'll draw ourselves a circle, and on the outside of the chart we'll put our possible exponents. We could have a 0, a 1, a 2, and a 3. So on the outside we have our exponents. On the inside we have our answers. And so we're going to think of these as exponents on I. Well, I to the 0, any number to the 0 is 1. So I to the 0 is 1. I to the first, any number to the first stays the same. That's I. I squared, we discovered, is -1. And I cubed, we discovered earlier, is -I. So there are my 4 possible answers to all the powers of I. If you continue counting around your circle through the problems we did on the other paper, we have I to the 0, I to the first, I squared, I cubed. This is I to the 4th is 1. I to the 5th is I to the 6th is -1, and so on. So if I needed to know what I to the 10th was, I could count around my circle. So if I wanted I to the 10th, I would say, well, there's I to the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. The answer is -1. Okay, so these are all different powers of I. Now, a bit of a problem happens if I ask you to find I to the 53rd. I'm really lazy, and I don't want to count around to 53, and if I'm not lazy, I could just make mistakes, because we all do. Well, since there are only 4 exponents on my chart, and only 4 possible answers to powers of I can go back to elementary school for a minute and divide that exponent 53 by 4. But instead of knowing fractions or decimals, go way back to the days when we thought about remainders. So if I divide 4 into 53, 4 goes into 5 once. Good old review of long division. 4 goes into 13 3 times. 3 times 4 is 12. I subtract, and I have a remainder of 1. Before we ever learned about fractions or decimals, we talked about remainders. Well, these exponents on the outside of my eye chart are also remainders. So, if I go to the remainder of 1 on my eye chart, inside is my answer. So I to the 53rd is equal to I. Get your eye chart into your cumulative notes and then go back to your paper. We're going to take some more powers of I and simplify them, and we'll use our eye chart and our long division by 4. So I to the 38, well, we can take 38 divided by 4 off to the side. 9 times 4 is 36, so this has a remainder of 2. Now you can either remember that I squared is -1, or look at your eye chart for the remainder of 2 and look inside for the answer that's -1. So I to the 38th is -1. I'll do one more with you and leave the other 2 for you to try. So I to the 21st, we would take 21 and divide it by 4. 5 times 4 is 20. We have a remainder of 1. Well, I to the first is I. Again, if you would rather always look at your eye chart, go to 1 as a remainder and look inside. There's your answer of I. So I to the 21st is also equal to I. Try C and D on your own.